Hello and good evening. My name is Aditya Chaudhary and my BITS Pilani ID is 2024AD05010. Today I will be showcasing the MLOps Pipeline Assignment 01 project which is the topic of heart disease risk prediction. So this is my GitHub structure which is using my BITS Pilani email ID, and it is containing all the important files and relevant documents which is used in this project. I am walking you through each of these files, and the best way to go through it is the readme file. So this is my project structure. The important part of the project structure is the main Python file. This is the Python file which I am using. This Python file is mainly used for analyzing all of the data which I have and predicting whether a person is having a heart disease or not. So let me give you a little bit of overview about this Python file. Two of the main algorithms which I have used in this Python file is the random forest algorithm and the XGBoost algorithm. So one of the main reasons for using these two algorithms is because of the different types of attributes which we are using in this project. In this case, we are having several attributes which I am showing you from the confusion matrix heat map. So this is the confusion matrix correlation heat map. In this one, as you can see, there are several attributes which are present. The age of the person can be related to the heart disease. Similarly, the sex of the person, the amount of cholesterol that person is having, the amount of blood pressure that person is having, everything of these relations can lead to a heart disease. So based on this one, these parameters, I am using the heat map for this examining the different parameters, and as a result of different attributes being used, I am using the random forest and the XGBoost because they work well when there are multiple attributes which are present. I have also added different types of bar graphs and histograms, like the distribution of age. So based on the parameter of age, how many person are likely to have heart disease. Based on the distribution of blood pressure, how many person are likely to have a heart disease, like this. So all of these different parameters and the histograms are present based on some of the attributes. This is what the overall Python project code is doing. In this one, there are different setups and different importing of libraries, different test cases, and some of the dummy Python test cases are also present, and there is some training and there is some execution as well. Based on those trainings, I have done some executions. So this is the file, main important file, which is having all the relevant data which is required in our project. Moving on into the next part, this is the document, the heart disease document and report. What this is doing is, this report is responsible for all of my important findings in the project. Let me walk you from the beginning. So in the beginning, again, I have added the GitHub URL. This is the GitHub URL which I am using for showcasing my project. This is the system architecture, all of the important steps and all of the important folders are present. The folders related to Grafana, Prometheus, and the folder related to the tests, and the folder related to the Dockers. So this Docker readme file is containing all of those attributes, all of those explanations as well. This is the architecture. The CI/CD pipeline is also involved in this project, and I am walking you through those shortly. This is again one of the relevant test cases and metrics which I was showing in the project part, and below these is the main functionality of this one. So this CI/CD pipeline is what I have built from ground up. So this pipeline is having 4 stages: the LINT, train, test, and Docker build. Whenever I am pushing any code into the GitHub, so in this stage, these 4 attributes are getting triggered: the Docker build validation, the lint push, the train model, and the unit tests. All of these test cases are getting executed, and once these are getting executed successfully, then only my code is getting pushed. The lint is responsible for setting up the job, installing the libraries and all of these parts, setting up mostly the Python libraries. The train model This one is responsible for training. It is cleaning the database and data set, and then cleaning, training, and then packaging. This is a fast training method, so that all the relevant data are useful in my training. And then the unit tests. The unit tests, about 20 unit tests I have passed. In this 20 unit tests, the relevant information are present, which consist of different types of JSONs. The JSONs contains the heart rate, attribute, cholesterol, different parameters. I'm also showing that through the Prometheus, then it will be much clearer to understand. And then there is the Docker build validation. The Docker build validation is the last step of the project. It is responsible for all of the compiling all of the above tests and then making a completion of the job. This one is important for making the complete walkthrough of the project. Now let's move on into the next step of the readme. Like, this is the training of the model. Requirement.txt is the main important file in this one. The requirement.txt file and the train.py file. These two files are using the training parameters. Now let me move on into the Docker Compose. So one of the important things which I have learned during the Docker Compose part is, in the local environment, when I was starting the Docker, during the initial stages, I was failing with the K8s. This is the Kubernetes clusters which are responsible for setting up of the Grafana and the Prometheus. So these K8s clusters were failing. Why was it failing? Because in this part, if you can see, I was not enabling the Kubernetes. This one was disabled by default. So this one was one of the important learnings of the Docker terminal, that you have to enable the Kubernetes manually from this part. So this is one of the learnings which I have gone through, and I can see over here these ones were all running in my local clusters. So local I have shut down, and as you can see, all of these are 0%. It was last started 3 hours ago. Now if I go into the APIs, let me go into this API once. This is the API. The API is containing, it is acting like a Swagger. It is an endpoint. So this Swagger API is responsible for like hitting up all of the request bodies. So the request body over here, this is actually coming from a test case. The testing file is present over there, which is containing one of these attributes. So if I go into the try it out method, and then if I try on execute, so as you can see over here, I have got, this is the request which I am passing, and this is the valid response for that. The response is showing with a confidence score of 0.55. That is a 55% chance that this person is not having a heart disease. Now if I pass on different parameters over here, such as if I make the age as 33 and then execute, you can see that this is again changing 55.9%. and if I pass this as 32 and then I make this as 133 and then execute, you can see there is probability confidence score of 60.6. As a result, you can get from this that this is a live demonstration and this is not a dummy URL. This is a correct part which is showing the confidence score according to the parameters which are being passed. So this is the most important part of the project, which is showing different types of parameters which are being passed, and they are responsible their respective confidence levels, confidence score, that whether that person is having any heart disease or not. The next one is the Prometheus. The Prometheus is responsible for my like status of the health, status of the different APIs, whether they are up or not, whether they are facing any downtime or not. So in this one, if I go into targets, you can see that this is my heart disease API, and if I go over here, you can see the different parameters which are responsible, and also it is showing a state as up, and this is the Prometheus dashboard which is showing as unhealthy, 0, collapse, and all. So this one is state is up, and green respects to up as healthy. So this is the Prometheus dashboard. And the third one is of the Grafana. The Grafana, if I can show you from here, this is the heart disease Grafana part. The Grafana part is responsible for clicking. It shows the metrics of the different URLs if they are clicked, and what is the metrics, how many times each URL is getting clicked, and what are their responses. If there is some alerting levels of clicks or auto clicking is happening, all of these things you can view from the dashboards of the Grafana panel. So this one is of the Grafana architecture. So this is the important three attributes which are extra added in this project, and also the relevant MD files and the follow through files of these parts are also present in my document. So Grafana architectures, Grafana screenshots, all of these relevant architectures are also present. Like this is the Prometheus, what is happening when I am passing the 200 response prediction, production deployment in Kubernetes, and then Kubernetes startup, what errors I was facing. So when I was making this GitHub token, I was missing the ID and I was missing the GitHub key, and I had also those relevant screenshots of how I had fixed those relevant key, and then I have given my ID, and then I was able to complete the GitHub push of the initial project. So all of these relevant informations are present. Now into the last part about the tests. The test part, which I have explained before, like it contains around 20 of the test suite parameters. The test suite parameters are responsible to check whether my model is having all of the relevant outputs, and even any of the code changes which I am pushing, it will go through the unit test part over here. So if I say over here, the unit test section, it will go to the unit test section in the GitHub, and it will give you the relevant test results, like that part is correct or not, or any of the attribute needs to be handled separately or not. So we can update and modify the test case as well. And these are the Kubernetes cluster, that Kubernetes clusters deployment and the service YAMLs. So this is the main functionality. All of these are built on CI/CD pipeline, the lean, train, test, and Docker build. These are the 4 different attributes which are working coherently, so that my project is showcasing all the important attributes. So overall, this is the project architecture in brief, and the relevant codes are also present. Thank you very much.